Hello everyone, thanks for being here. My name is Kaina. I'm a first year PhD student at Duke University, and today I'm gonna talk with you guys a little bit about this study that I'm doing right now with my group, the comparative analysis of water sorption in mortar with olivine sand capture using 4D X-ray CT. Basically, why we wanna see the sorption? Why is that important for us? Basically, it's because sorption is directly linked with durability. So if we have like a very durable material, we have to look at it. And why I want to use olivine? And actually is because this is the reason that I'm gonna show you guys in this presentation, so just stay still for a little bit. Okay, so a little bit of the background in sorptivity. When you have cement tissue materials, basically you're gonna have water into a porous media. The water is gonna first fill the small pores, the capillary pores, and then it's going to fill the bigger pores. This is important for us to show. Also, this study from my advisor. So basically, she was using some gas injecting in the porous media. It was basically CO2, methane, and nitrogen in 3 different samples to see the results of the sorptivity, if that's going to just like affect that somehow. For this study, unfortunately, we didn't have like a lot of results for the sorptivity in the capillary pores because of the limitations of the CT she was using by that time. But that's actually the results we wanna see if we can achieve using our CT machine, because it's like more powerful. So if we can see that in our machine, it's gonna be much better. So that's what we're expecting to do. Okay. The motivations we have for this research. Sometimes we just like talk a lot about sustainability and everything else, but we actually don't just delve deep into this this solution and what this really means. So basically, for this solution for sustainability, we have the United Nations that just defined as equitable, economic, and environmentally balanced solution, and that's what we're looking for in this study. So basically, we have like 3 bullet points that I wanted to discuss. We know that we need to lower the carbon footprint in the concrete industry. That's like something that everybody knows that already. And also, we know that concrete and Portland cement already capture carbon dioxide naturally in the carbonation process we have. And also, we know that in nature we have an enhanced rock weathering that also capture carbon dioxide from the atmosphere. So if you can use that to accelerate carbonation into our materials, it's going to be amazing for materials, because you're just like going to blend 2 materials that capture carbon dioxide together. And also, if we integrate that with magnesium-rich materials that we have, which basically olivine as well, we're going to have like those 2 materials that capture carbons into one material. So, I mean, it's a win-win condition. And also, we just don't want to provide some solution that is environmentally correct, but also we want to provide solution that is also like good for durability and also good for economic purposes as well. Because you need to have an economic viable solution for you. So this is the general objective for our research, just to develop a sustainable engineered geomaterials using carbon capture, utilization, and storage. That is basically our research goals for now. Okay, the material is going to use. I mentioned to you guys about olivine. The olivine we're using right now, it came from Norway. Why Norway? I mean, why you have to go all the way there in Norway to get olivine? Just because they have there the largest commercial mining company of olivine. So we just decided to take an olivine that's already like pure, so we could get in and compare the results with the olivine we have in North Carolina. I mean, we have some samples from olivine in North Carolina, because if you can compare the olivine, this material we have in North Carolina with the olivine we got from Norway, and the results they match together, it means we don't have to go all the way down to Norway, to get materials for us to come up with solutions. You have the solutions here in the US or North Carolina itself. This is our goal for now. Some methods. I talked a little bit about carbonation. I think most of you already know, but basically our study just how to accelerate carbonation into our cement-based materials. Because we know that carbonation, we have the carbon dioxide in form of minerals after we have the hydration products into the cement. And we also know that olivine is not an inert material as the regular sand we use. So after the hydration of semen, we have like the formation of the carbonates into the semen, which the main one is the calcium carbonate into the semen, which is the most important compound we have after the hydration. But you also know in the olivine, we also have a compound after the hydration, which is basically the magnesium carbonate as well. So we know that in the olivine, we also have carbonation, and we also have carbon dioxide mixed to it and mineralized to it. So we also can bend carbon dioxide inside the olivine. So we have carbon capture in the semen and also in the aggregate, which is amazing for our purposes. Okay, some methods that we're going to use. We're going to use this ASTM that just like talks about the sorption test that we're going to use, and also of course our CT machine that we have in our lab is a very powerful CT machine, and this is a little bit of how it works. Basically we have the X-ray source for this CT machine, we have our material in the middle of the X-ray source, and we have our detector. So after we have the X-ray source, he's gonna like send the X-ray, and he's gonna interact in different forms with the material you have, depending on the density and the materials that we have there. And then we're gonna have the results into a stack of images that we can do like the slices, and also we can do segmentations. And after the segmentations, we can get the 3D model that we can study better, just like not using the sample itself, but we also can using it just studying in the computer or anything else that we might need for, as a 3D model. About the CT, the scan itself, it depends a lot on what you want to see inside the CT. If you want a very like high resolution CT, is because we want to see like very deep into the material. This is the difference of a very less time of CT and then a very long exposure of CT. So you can see the difference. We can have a very good look into the material you're going to use. So this is going to be very important to our research in the future when you want to see like the materials we have inside, the hydration products and everything else. This is one of our scans that we had. It's a test scan that we performed into a core in a sample, a concrete sample we had. It was very porous, so we used just a very very high Ki solution, so we could see very better the water just coming up like capillary in the pores. So we could see like if we could see that in our samples, so we could use that in the future research that we're going to perform. This was a less than 15 minutes scan, so the results is very nice because it was not a long exposure result. And this actually also explains why we call it 4D, because we have like the three cross sections and also the resolution and the progress based on the time, so that's why it's 4D. And also we want to test it with lower doses of Ki, so we don't have like to use like 30%. If you can see like with those lower doses of Ki, it's going to be much better for our research, so it doesn't affect the chemical composition of the sample we are using. So this is a little bit of some of the results and the samples we are using right now. So we just produced some samples using regular sand, like quartz sand base, and olivine sand. The samples were made with 0.6 water cement ratio, and 40% of the volume were sand. So yes, our objective was just to make like very porous samples, just for us to see inside the material and see if we could like check the porosity and also the water absorption on it. These were the results of the scans we performed. In the left side, the left side of you guys is the regular sand one. In the right side is the olivine samples. We can see a little bit of difference. We can see some blank spots there, like white spots that I'm going to show you guys later with the results I got from Dragonfly. I got this part of the samples for me to analyze, so I don't have to analyze the whole part of the samples because it will be like a very like large data. So for me to just like get these slices was easier to get this. And this was the result after treated. You can see a little bit the difference already, like in the olivine samples and the control samples. In orange, you can see the high density materials. It is reasonable that we have more high density materials in the olivine samples because the olivine sample has like a wide composition of minerals, so it's reasonable for us to find more like high density materials in the olivine samples. But what really interests us is just like the porosity inside the samples. We can see that the olivine samples we have, it has less interconnected pores, which for us and for durability purposes is very good because you can tell just by looking at it that we can have like more durable materials using olivine. So if you have a durable material using olivine, and also you know the olivine and cement itself is going to capture carbon itself, so it's a very good like environmental friendly solution. Let's put it like this. So this is very like a promising results for our research, just for us to apply in different methods in future research as well, because I mean we don't have like that much interconnected pores. One of the research that we wanna check is just like quantifying all the interconnected pores, and also how much difference we have like pores from olivine samples and also the control samples. But that's a 3D model that we're gonna work like in future research, so we can have like this material, just like the whole material, just not one slice, to see if that just like is going to apply for the whole core of the that we are analyzing. For the future works as well, I also wanted to expose the samples we have with a high concentration of CO2 to see the reaction of that, and see if with the high exposure of CO2 we can accelerate the carbonation of the samples, both the quartz sand and also the olivine sand, and see the differences that we're going to have in both samples. And also I want to complete another CT scan after we do that to see if there are some changes into the material you're using. And also we're going to conduct another sorption test to see if the sorption decreased or increased or something like that, because by the sorption test as well we can tell like a bunch of mechanical and chemical properties after the analysis is going to perform. And also we want to quantify the CO2 mineralization using TG analysis that we have at Duke as well. So there are a bunch of works that we still wanna do, but I mean I think we have very good promising results just by the scanning we performed. So yeah, I hopefully we're gonna have some good results by this research as well. So this is the acknowledgements of this research. Our group, I think you guys already saw that picture today, and hopefully we're gonna see that tomorrow again. But yeah, this is us. I hope you guys enjoyed the presentation, and thank you for your attention.